So you know how to measure volume, you know how to measure temperature. For now, we are assuming that when we're talking about a sample of gas, the number of molecules is not changing at all. Pressure we started to talk about last week. And we went through the whole, you have a 6-mile cylinder of gas sitting on top of your head, and the weight of that is pushing you down into the earth. That's pressure, because pressure is the amount of force something can exert over the area it exerts it. And if you think about having somebody press a brick onto your back versus press a thumbnail into your back, which one feels worse? Thumbnail every time. I can tell you from personal experience that toddlers have this, and preschoolers have an uncanny ability to concentrate all of their mass into one pointy little elbow and jab it into a sensitive part of your body. It's this like crazy radar they have. Ooh, where's the most delicate spot that I can possibly push all of my weight? That's pressure. It's the amount of force per unit area. So evenly over your body, the atmosphere is pushing on you. And it's amazing that you can even walk around. Fortunately, you and all the other living things here evolved into the amount of pressure we've got. So if we put you in a much lower pressure environment, like space, as you get into the upper atmosphere, the pressure inside your body begins to overwhelm the pressure outside your body. Things start to puff up. Eventually, you would actually explode. We put you in a much higher pressure environment, you compress, because you're built to work at this kind of atmospheric pressure. And when we get too far off normal atmospheric pressure, there start to be effects. So that's what pressure is. We're going to do a little bit with pressure conversions. So these are pretty simple. Here's just one more definition of atmospheric pressure. It's the pressure exerted on everything on the planet by the gases in the atmosphere. We measure it, well, there are a couple different ways to measure it. Newtons per square centimeter. Do you remember newtons from physical science? Again, did I have a freshman year? I don't remember it. Newton is the unit of force, and it is mass times acceleration. 1 Newton of force is about the amount of force that it takes to lift your average apple from a table to your mouth. That's about 1 Newton of force at a constant velocity. The tool that we use to measure atmospheric pressure is called a barometer, and I just so happen to have one here. And this is my least favorite barometer of all time. My favorite barometer of all time somehow got lost in the move. I have no idea where it is. And this one actually measures in hectopascals, which is like the stupidest thing I can imagine. But we'll learn how to convert it. A barometer is just a device that's measuring atmospheric pressure. And the simplest way to do that, well, let me show you a little game. So when we talk about normal atmospheric pressure, we're talking about an absolutely normal day, sort of the averagest day you can imagine, and we're talking about it at sea level. Why is it important that we specify sea level? What did we talk about Friday?
Because it differs in height.
Yeah, because atmospheric pressure does what as you go up higher in elevation? Decreases. You've got the column of air pushing on you is shorter. If you go down in elevation, what happens to atmospheric pressure? Increases. There is a salt mine underneath Lake Erie. It's about 2 miles deep, and the air feels rich and cool and wonderful. If you ever get a chance to go there as part of a college class, do it. Do not miss the opportunity. I got to go there once, and it was amazing. I would love to organize a field trip for us, but I don't know that that'll ever happen. So when we say normal atmospheric pressure, we have to specify at sea level. We also have to specify temperature. And when we're talking about absolutely dead standard average, we're talking 0 Celsius. What is that in Fahrenheit? 32 degrees. Yep. So cold. This is cold. And we call that 1 atmosphere. And here, an atmosphere is actually a unit of pressure. We're going to have a couple different units of pressure, but an atmosphere is actually a unit of pressure. So the units for pressure are all derived units, which means they're a combination of things, just like density, which is mass per unit volume. This is force per unit area. So we can say it's newtons per square centimeter. We can say it's newtons per square meter. The Pascal is 1 Newton per square centimeter. That's pretty low. That's not a lot of pressure. So you're talking about basically what we think of as the weight of an apple pressing down over an area of a square meter. That's not a lot of pressure. So usually we would express, we very seldom actually use pascals because they're so cumbersome to deal with. So kilopascals are more commonly used, and 1 atmosphere equals 1.01325 times 10 to the 5th pascals. See how cumbersome that is? Or 101.325 kilopascals. If you would be so kind as to look at the table in your book on page 311, we're going to walk through doing a few pressure conversions. So grab a book. Okay, so what you see here is a unit, that a little chart that just gives you 311. So this chart just gives you some of the different units that we're going to use. There are pascals, millimeters of mercury, torr, and atmospheres. Of these, for absolutely no good and rational reason, I love torr. I don't know why. I don't know if I like the way it sounds. I don't know what I like about it. What I can tell you is it gives you enough digits usually to get good significant figures. So you can use any of these, and you can convert among any of these. And here's the neat relationship. So 760 millimeters of mercury. And do you know where they get such an obscure measurement? That's actually the literal height of a mercury column in an old-fashioned barometer that's just a mercury column. And we could actually leave this sitting here, and you could take a measurement today and watch that column rise and fall. We're going to have a low pressure front coming in sometime tonight. It's supposed to start sprinkling, and we're maybe having some thunderstorms. Typically that means a low pressure system. And as the atmospheric pressure dropped, you would actually see, if you took a reading on this column of water today, you would actually see that column of water drop. Mercury was used because it was easy to calibrate, and it's very viscous, and it was deemed to be much more accurate than just a simple column of water or alcohol or any other fluid you can imagine. But you could really use you could use like a honey barometer, which would be a sticky giant mess, but it's viscous anyway. Okay, 760 millimeters of mercury is equal to 1 atmosphere. Well, that's easy. And 1 atmosphere is equal to 760 torr. And 1 atmosphere is equal to 1.01325 times 10 to the 5th kilopascals. And 1 atmosphere is equal to 101.325. Oops, I'm sorry. That one should have just been pascals. My mistake.
10 to the
10 to the 5th, yes. Impossible to read. Let me improve that somewhat. There, that's better. Kilopascals. So right off, what do you see about torr and millimeters of mercury? 1 torr equals 1 millimeter of mercury. Torr is almost just another word for millimeters of mercury. Kilopascals and pascals, obviously that's just applying a metric prefix to an SI-derived unit. And the pascal is actually the SI unit. I just don't like them. They're cumbersome. But, you know, I don't get to pick. So let's do 1 or 2 conversions together. And then you'll probably be ready for your 4-minute break. So you can use any of these conversion factors. Let's say that you're told that on a given day, the atmospheric pressure in this room is 782 torr. I want to know how many kilopascals that is. What do? It is just a simple factor label. So what do you start with any factor label? Given. 782 torr. Units to cancel on the bottom. Torr. Units to go into on the top. Kilopascals. But wait, you say, I don't seem to have a direct conversion between torr and kilopascals. Do you? Sure you do. Because 1 atmosphere is equal to any of these things. So these things are all equal to one another. So 760 torr, which is equal to 1 atmosphere, is equal to 101.325, 101.325 kilopascals. It's actually that simple. So if you don't have a calculator already, go grab one. Okay, so you all have a raw answer like this, 104.258, etc. How many sig figs can you have? 3. Because your given, which was 782 torr, only had 3. So your final answer is going to be 104 kilopascals. Now, to eyeball that, and you'll get more accustomed to these as you use some of them. If we're saying standard atmospheric pressure is 760, 782 is slightly above standard atmospheric. This is a high pressure day. High pressure days, if we think about atmospheric pressure outside, tend to be bright, clear, not a cloud in the sky. Those tend to be high pressure days. Low pressure systems tend to bring clouds, drizzle. A lot of people will feel pressure changes in their sinuses. I swear I can. Okay, so 782, slightly high pressure, above normal atmospheric. When you do your conversion, is this also above normal atmospheric? Yes, because 1 atmosphere, normal atmospheric, is 101. So your units are going to be different, but you should always sort of be ending up on the same side of that normal atmospheric. Okay, for normal atmospheric in whatever units you're converting to. Okay, let's do one more. Yeah, we'll do one more, maybe 2 more, and then I'll assign you some practice on these. Okay, so here you're told that you have, and this would typically, a pressure this low would typically be like in some sort of vessel, in a container of some sort. You've got something that's under basically a half an atmosphere of pressure, 0.5279 atmospheres of pressure. So this is just over half of normal atmospheric. This is a very low pressure environment. You could actually get this up at high elevation, like in the Himalayas. What we want to know is how many millimeters of mercury is this equal to? So you're starting off, of course, with your given. And your units to cancel will be ATMs. Units to end up in will be millimeters of mercury. 1 ATM is how many millimeters of mercury? 760. Okay, you got a raw answer that looks something like this. 401.204. How many sig figs do you get? 4. 4. So we're going to stop right there. So our final answer would be 401.2 millimeters of mercury. Now, to apply that same sort of test that we did with the last one, 0.5279. This one's pretty easy because, of course, 1 is standard atmospheric pressure. Approximately what percentage of normal atmospheric pressure is that? A little bit over half. And you know that 760 millimeters of mercury is standard atmospheric pressure. 401, is that a little over half? Yeah. So you just kind of get a sense that, okay, that conversion, I didn't screw something majorly up. If you do a conversion like this, and this is roughly half of atmospheric, and what you get is like double atmospheric, there's a problem. You need to go back and look at it. So that's just sort of a mental self-check. Okay. Questions, comments, concerns? Do you want to do one more together?
Are these ever going to be more than one step?
Nope, never. And one year I had a student, and it was I'm glad you asked that, because it was, I never thought that somebody would think that they had to go through all of these, and they thought to get from here to here you had to go through atmospheres, and then torrs, and then kilopascals to pascals. And so they were doing very, very, very long, cumbersome factor labels. And I felt very, very bad when I realized that. You do not ever have to do that. You can go straight from any one of these pressure units straight to another. It is always a one-step conversion. There's never more than one step on these. Okay, other questions, comments, concerns? Yes, ma'am.
On tests, we're going to have to memorize those numbers, right?
Typically what I've done is I put these up at the top of the test or the quiz. Because I think it's kind of stupid to have you memorize a bunch of standard atmospheric pressures when you would just go look that up anyway. Once you've used it about so many times, you're not going to need to even look. But I'm not really interested in having you memorize that. I think it's silly. So you'll have it memorized. I mean, you'll have torr and millimeters of mercury memorized like in the next 15 minutes. But no, I don't want you to waste a brain cell on that one. Other questions, comments, concerns? Okay. Okay, so assigned on these, page 312, that's a section review number 4, and then the chapter review number 16 and 17. And I'll give you a few minutes to work on those, get through at least the first couple, and then we'll move on to some other stuff.